Okay, so first I'm going to show you a Hello World actor that has been written in AssemblyScript. So this is a similar actor that we have seen from Rust and Go. And I'm going to a little bit show you what Zondax has been added to improve it. So, okay. Okay, can you see the code now?
Yep, looks good.
Okay, so this is a say hello actor. It's different from Rust. I don't know if you noticed, but there is no invoke function. Basically, because there is some part that it's added after, that is added at compile time, that is to simplify the code. So we only have the constructor function in it, and we have decorators. So here it's defined that is a constructor function, and that is being called when the actor is being created. In this function, we have a state. We just give it the default state and save it. So it will be saved in Lotus, in Filecoin, sorry. Then here we define a say hello function. So same like in the Rust. We also have this function that is method that is being called by method 2. And this is what this line is for. We basically explicitly tell that is going to be a exported method that has the number invoke method number 2. And we have the parameters that are being passed to it. So, well, here we don't have actually parameters for this function, so it's not being used, but it's still there, so it can be used. We load the states and we count. So we have a counter in the hello world contract. We increase it, we save it, and here we return a message which is hello world and the state, like the counter. So far so good. So I've been able to really simplify the actor thanks to those decorators that we had before, and hide a lot of the complexity with the invoke function, etc. So here we have a state, and same, we are trying to keep it minimal. And so it's an extension to the base state that we can find in the FVM SDK, and the state we just define here as a counter, like count, which is a integer. And so now we can build it if it's working. Okay, should be good. Yeah, okay. Okay, so now it's generating from the assembly index code. So the code that we just saw, we are generating the WASM bit file. And where is the WASM? Okay, so it's here. So we actually have two WASM files. It's because, I don't know if you remember, but we were like a bit, we were having some issue with WASM, is that in Filecoin, you are not able to call any function before the invoke, the famous invoke function. But in WASM, it's supposed to be, it can happen. So you can have a specific start function that is going to set up the memory and some stuff before. So what we do, we have an intermediate phase that actually going to run it before and recompile into WASM, another WASM file. That's why we have two WASM files, and we only use the final one. So, but this, yeah, people need to be aware of this, but it doesn't quite matter once you know how to do it. So yeah, we have the we have our WASM file, and should I? Okay, let's try to run it inside the DevNet. module. So it should be built. So I'm going to copy paste a freshly imported, freshly created WASP file. Okay, connection lost. That's not great. Oh yeah. Okay, so now we should be able to install chain install. No, this is not this one. Okay. Okay, we have it. Chain. I'm sorry. Okay, we create the actor now. And it should be here. So here we have the newly created actor. And now let's try to see and call invoke to chain invoke. Okay, and here we have our message. And if we decode this, it should be the message that we want. So let me try to find the C-board decoder just so to make sure. Basic C4 decoder. Oh, sorry. Okay, and here, so we have hello world 1, so the counter has been updated. Let's see if we can do it again and see if it's keeping the state.
Lola, can I add something there?
Yeah.
You that? I mean, what we are doing there is we're using the decorators to recognize key points or key parts of the smart contract and add all the Filecoin related code for the smart contract to work. In the state class, we are adding all the encode and decode functionalities to serialize and deserialize the fields of that class to a stable structure, a stable array. And we are doing that by recognizing the fields that the user has set on the state class and using the types and the default values to create the default value, the default class, the default state for you to save. And then when you run the load function, we do all the stuff to load those values from the stable array to the state class so you can consume it from the site. The same we are doing for the other those two decorators, the constructor and the invoke. We are taking the invoke function and the number you pass there to create the invoke function, the whole function with all the values. And if there is, do you want to define any export method, you can have only the constructor. If you don't want to have the constructor, you don't need to define it because you don't want to save anything in the initial state. So you can also use the export method. That's the magic. That magic is happening before compiling the code by another package that we have created. And that's something that AssemblyScript allows us to do. Sorry for interruption.
Oh, yeah. So, yeah, you're talking about, yeah, so the generated file, and then that they are after compiled into WASM. So there is an intermediate file that is generated with more code, but using the decorators allow us to keep it simple. And Okay, so now we have seen that Hello World actor works. The FVM SDK is working and complete. So we can generate WASM file. And we also, so with Zondax, we also had to create a Cyborg library to encode and decode that is works with AssemblyScript. And we were also interested in doing a benchmark actually to compare. So then what is interesting is to compare what's the advantage with Rust, the advantage with AssemblyScript and Go, like to see the differences. Are we doing worse or better? So we were able to benchmark. So we were able to get the already write an Hello World contract and just create a small script that will compare the gas used and the file size. So it should be, it will show in a second. Okay, it's a bit long. Okay, running the benchmark. So it's compiling the Go one and the Rust one. And we are using the local FVM to get the gas used. So we can see that the Rust actor is, when we call the say hello function, is as the best number in terms of gas. Then we have the AssemblyScript. And so we have different flavor of AssemblyScript of the WASM compiled from AssemblyScript. The stub is the one without garbage collector. And we actually have the best, second best gas used. By that, I mean, it's using a bit more gas than Rust, but less than the other. And the Go actor is actually using more than twice than the Rust actor. Regarding the file size, it's actually the AssemblyScript one that is the smallest, allow to create the smallest file size actor. And
that's amazing.
Yeah, okay, that's cool. And so we also made like a couple of more contracts, so to play with it and see if we actually have the FVM SDK at a limit. So we had the ERC20 actor right there in AssemblyScript. Where it is. Okay, that's here. So we have all the methods that you would find in the ERC20 contract. So get name, symbol, decimal, total supply, etc., etc. We can do build. Okay, do you want me to build and run it in DevNet, or do you trust me that it's working? I don't know if it's interesting for you or not to see this.
Maybe what we can compare, Lola, there is if we have some benchmarks. If we, I don't know if we were able to do it yet now or it's not there yet. But
oh no, we don't have the benchmark for ERC20 actually.
That's something that we will do because we want to compare and see with every example that we have available, if we can compare how well we do with AssemblyScript. I mean, I guess we have the Golan example, so we will add it in the next demo.
So yeah, we don't have the benchmark for ERC20 actor, but yeah, basically it's the same. We compile, we have the WASM, and we can call invoke, but I think I will pass on it. It's a bit slow, taking a bit of time. Because yeah, so another contract that we we're working on is also a Filecoin naming system. Filecoin naming system one. So this one is simple, it's custom, is not matching anything that has been done in Ethereum or whatever. We have basically a register and a transfer, And so that's also linked to a question and something that I want to show you that I asked yesterday to the FVM team, is that we noticed that when you do resolve address, you will not, if the address is not, has never been used on Filecoin, it will resolve to 0. So this is, I'm going to demo something that is not working this time. Oh, again. So if we do make build.
And this makes for a great feature request.
Yeah. Oh, actually, we also like, we are, while developing it, we are thinking about what would be the best practice, because here we notice that if you use our SDK and are not careful enough, you are going to do something that's actually going to lock you away from your RC20 token or Filecoin name. So that's why I wanted to show you that. Maybe people have noticed something similar. Let's see. Oh, that's not this. Sorry, what's the name of the file? Okay, fil. And here, if I do Lotus chain install actor, create actor, okay, it's working. And let's do invoke. Forgot. So here I'm going to register name, but like I need to, so it's method 2, and I'm passing basically the parameter in base 64, and yeah, I think it's zondax.fil that I'm registering. So, but because it's me that is sending it, it's going to register to my actor ID, caller ID. So then now if I do Lotus state get actor, and I'm going to check the state. Okay, here we can see that, so I have a counter, I've registered one name, it's Zondax field, it's registered to me, and my actor ID is 100. And now let's do a transfer. So transfer is method 3. Let me find this, yeah, somewhere. Okay, and if we do the same and we look at it, so I've transferred it to, so what is in the parameter is actually the name of the file, so Zondax file, zondax.fil, and freshly generated accounts. So that has never been used before. And here it has been registered to 0. So I actually cannot use this domain name ever again. So yeah, this is an issue that we found out. And now the goal to improve, it's actually to improve the SDK to not allow developers to have things like this. So make it bulletproof to bad practice. And to so also to improve how we encode and decode, because like Emma was saying earlier, is that the CBOR is only able to do it for basic types, but we want to be able to do it also for custom types. So like address, That would be nice. So it will automatically generate encoding and decoding. And we were also looking into having a JavaScript FVM, local FVM, but for testing. So basically like you have in Rust, but because we know that JavaScript developers or people who would be more inclined to use the AssemblyScript doesn't really like Rust. So they would stick with a JavaScript-like language. And that's all.